Welcome to the video series on learning your multiplication facts. As you know, this is a third video in the series. We've already looked at strategies for 2, 4, and 8. We've looked at strategies for 10, 9, and 5. And this video series will talk about the remaining strategies, which are the 3, 6, and 7. So once students are proficient with the previous two sets of strategies, you want to introduce them to the remaining there's about 7 left facts to know. All inclusively, there are 100 facts for students to learn and to know. And it's important for students to see that 3 times 4, 4 times 3 is the same, but they usually get that at that particular point. So once we have that in mind, when we multiply by 3, we've already done the majority of the times 3 table. We've done 3 times 2, we've done 3 times 4, we've done 3 times 5, we've done 3 times 8, 3 times 9, and we've done 3 times 10. So what's left is 3 by 3, 3 times 3. For students to really understand that, a good idea would be to draw your rectangle. If they have Lincoln cubes, they can play with Lincoln cubes, or you can get them to just draw a rectangle. One side measures 3, the other side measures 3. What's the area? Either to see 3, 3, 3 would be your 9. When students know the answer from 3 times 3 is 9, it will be extremely useful to find the other missing fact, which is 3 times 6. At this particular point, students are quite familiar with what happens when you double the length of one side. What happens to its area, the area of the whole rectangle doubles. So for the 3 times 3 to the 3 times 6, that same thinking must apply. So when you think about 3 times 6, what you're really doing is looking at a 3 times 3 and another 3 times 3. So 3 times 3 is 9. You'll have 2 rectangles with an area of 9 that you've put together. Really, here's not rectangles, they would be squares. 9 and 9 is double of 9. Most kids would know it's 18, and that's how you would get your 3 times 6. The other one that's left in that pile is your 3 times 7. 3 times 7, unfortunately, doesn't have a nice doubling pattern or anything exciting that happens. The reason is that both these digits are odd and that there's no pretty thing. So that the one thing here that we get students to do at this point, just to memorize this, when I make up this little song where I just pretend, when they brush their teeth, they have time to wait. I say just sing a little song and say 3 by 7 is 21, 3 by 7 is 21, 3 by 7 is 21. And eventually it attaches it to their memory, because they practice so much, and there's just really one here to memorize. But if you really wanted to link it to a strategy, you could also think that 3 times 6 is 18, and then you're just really adding one group of 3, and 3 more than 18 is 21. So that would be the more mathematical way of thinking about it, linking it to something you know. But again, just memorizing that one certainly wouldn't necessarily hurt you, since there's just really one here to memorize. So that would conclude your 3 times table. So once students have versed it out with the 3 times table, you would want to move to the 6 times table. And again, like you probably know, now we've extensively increased the 6 times table. So we've done 2 times 6, we've done 3 times 6, we've done 4 times 6, we've done 5 times 6, we've done 8 times 6, we've done 9 times 6, and we've done 10 times 6. So the only 2 remaining are 6 times 6. So we'll talk about that one first. If you recall, the one we saw just a minute ago was the 3 times 6, right? 3 times 6 is really half of the 6. If 3 times 6 is 18, 6 times 6 needs to be the double for the same reason. One length of the side will double. So again, this is 3 by 6. If 3 by 6 is 18, well, 6 by 6, you're just increasing it by 3. You're adding that exact same area. So by doubling the area, you get your 36. Double your 10, get 20. Double your 8, get 16. Put it together, you get 36. So 6 by 6 is 36. So that's one that was missing. The other one that's missing is your 6 by 7. And I think of your 6 by 7, again, you would think, okay, well, 6 is an even number, must have a half. The half would be 3 by 7. Remember your 3 by 7, you know, because it's 21. You recall that one. 6 by 7 must be the double of 21, which is 42. And that's it for your 6 times table. There was 2 facts left. And that leaves us with the last times table, which is the 7 times table. For the 7 times table, you've already done every single times table. You times 7 by 2, by 3, by 4, by 5. You just did the by 6. The one missing is 7 by 7. And that's another one that really doesn't have any fancy thing. And 7 seems to be that one number in our number system that acts differently than the others. A lot more difficult to find patterns with the 7. So one strategy you can use for the 7 times 7 is just think about the 6 times 7, that was 42, and add an extra group of 7 to get 49, or just memorize with your song of 7 by 3 is 21, 7 by 7 is 49, and just sing it while you brush your teeth to really attach it to your long-term memory. And that concludes all of the multiplication facts. Like you saw, we covered 100 multiplication facts broken down into 3 groups. The purpose of that was so students could problem solve their way through learning their multiplication facts rather than basically solely on their language memory, which is their memorization. I want students to know their math facts using their math brain, not their linguistic brain. So this concludes the series on multiplication facts. Again, if you have any questions on these ones, you can watch the first 2 videos and really get the full picture of multiplication facts. Thank you.